So we already learned the difference between similarity and dissimilarity. Okay. So I would like to review one more time. If it is about the similarity, it often falls in the range of 0 and 1. And if it is dissimilarity, it is the minimum is 0, and then we have the upper limit varies. Okay, so varies means the upper limit can be like 1,000, okay, or it can be like 1,000,000, okay, and so on. And both of them are for measuring how alike or how different are two data objects. If the value is higher, then the objects are more alike. On the other hand, the dissimilarity or the distance shows that lower when objects are more alike. So that's the only difference. And sometimes we can use proximity to see about the similarity or dissimilarity. We can have data matrix. In the data matrix means we have the points. So we know about dimension. The dimension can be attribute. It can be variable. The data point means example or the instance. Okay. So if we have the attribute 1 and this is the object 1, then I can say this is x11. And I have the attribute f and this is the object 1, then I can say this is x1f, and so on until we have the dimension p. Okay, this is about the data matrix. But if we are dealing with the dissimilarity matrix or the distance, we will have two data points. Okay. So I want to know the distance between 1 and 1. So I want to know the distance between data object 1 and data object 1. So usually we can say the distance is 0 because the data 1 and data 1 are the same. But if we have another distance like this one, d2, 1, then it is the distance between data object 2 and data object 1. Most probably we will have a triangular matrix. And yeah, it is a single mode rather than two modes. Two modes means like 2 dimension. Okay, 2 dimension of matrix. So this is the x11. So it means this is the row and the column, and they are different. But this one, the row and the column, they are the same. So we call it this as a single mode. So the proximity measure or the similarity we can use for nominal attributes and we can use for the numerical attributes. Let's say we have the nominal attributes at this moment. So it can take 2 or more states. So yeah, you can use like red, yellow, blue, green. Okay. So these are the color. Okay. Or it can be some generalization of binary attribute like 0 or 1. Let's say if we are doing with the simple matching. Okay. So this is the example or the instance. We have person 1, person 2. And the person 1 is using the red shirt with black pants and white shoes and yellow hat. But the person 2 is using blue shirt, black pants, white shoes, and orange hat. So if I want to find the simple matching, I need to measure. M is the number of matches and P is the total of the variables. So how many variables do we have here? How many variables? You have? That's right. You have 4 variables. Okay. And among those 4 variables, how many variables that they are matches? Red and blue. Do they match? No. Okay. Black and black. Do they match? Yes. White and white. Do they match? Yes. Yellow and orange. Do they match? No. Okay. So 2 variables are matches, are matching. So we have 2 variables are matching because the 2 person are using the same black pants and the 2 person are using the white shoes. Then if we want to fit into this formula, what is P? P is the total variables, which is 4, and then minus M. M is the number of matches, which is 2. And then we divide it with the number of variables, which is 4. So the total will be 2 divided by 4, and we have half. Okay. That's the simple matching. Or we can use a large number of binary attributes. Okay, what does it mean by a large number of binary attributes? We can change the format of the data into 0 and 1. Okay. So we create a new binary attribute for each of the M nominal states. So we can see the person 1, and then we can make a new attribute, the attribute shared red. The data shows that the person 1 wear the red shirt, but the person number 2 didn't wear the red shirt. So we put 0 here and we put 1 in the person 1. What about the blue shirt? The blue shirt is in the person 2, but not in the person 1. So it means if the data equals to 1, then it is true. And if the data equals to 0, it is false. Okay. And this is based on the data that we get from here. So the shirt red for the person 1 and the shirt blue is for the person number 2. We can have the 0, 1, 0, 1, and so on. And we can match this one, each other. So doing with this binary, it will be easier to calculate because 1 and 0, okay, it does not match. 0 and 1, okay, it does not match. 1 and 1, okay, it matches. 1 and 1, it matches. 1, 0, it does not match. 0 and 1, it does not match. Okay. So we can have like, okay, in this case, we have the among 1, 2, 3, 4, 5, 6, there are 6, okay, and 2 of them are matching. So this is a kind of representative. There are some other ways to measure. This is not simple matching. Okay. If it is simple matching, then you need to use the current attributes. Okay. Current attribute means you have only 4 attributes. But because we expand this one. Red shirt is 1 new attribute. Shirt blue is 1 new attribute. Then we cannot use with this kind of measure. Okay. So there are other ways to measure the similarity or the proximity between the data. I will not discuss this one, but this is a representative that you will use later for the association rule. If we want to have the binary attributes, okay, so we can use like this one. This is a proximity method for the binary attributes. We have the binary data, and we want to create a contingency table. What is contingency table? In this case, I have the object I and I have object J. And I want to know if this one is 1 and the object J is also 1. Okay, so yeah, we can have the previous one like this one. If object 1 is 1 and object J is 1. Okay, this is not okay. So this one is 1 and is 1. Then we have Q. So sorry. Yeah, we have the if the object I is 1 and the object J is 0. So we have like number R. And if the object I is 0 and the object J is 1, then we have like S. If we have the object I is 0 and the object J is 0, then we have like T. So those are any numbers. And yeah, we can do like Q plus R, Q plus S, R plus T, S plus T, and the total will be P. Okay. If we want to measure the distance measure for symmetric binary variables, we can use this formula. R plus S, R plus S divided by Q plus R plus S plus T, or this one can be the same with P. But if the distance measure for asymmetric binary variables, we will use this one. So we will omit the T. Okay, we will not use the T for this one. My question is, why? Do you still remember what is the difference between symmetric binary variables and asymmetric binary variables? What is the difference? Any idea? If we have gender, female and male, is it symmetric or is it asymmetric? If we have female and male, is it asymmetric or symmetric? Okay, I get one answer. What about the answer from other student? Okay, Lee Hyun-ji, thank you. Kim Hee-kyung, thank you. Okay, what is the opinion from other student? Symmetric or asymmetric if we have female and male? Symmetric. Okay, that's good. Okay, so if we have female and male, we have a symmetric binary because there is no difference between male and female. But what is asymmetric? We have the, for example, case in the COVID-19, we have positive and negative. So we want to know more about the positive. So if you have the positive, then yeah, we need to handle case. We need to do some care, health care for the positive case. But for the negative, yeah, it's only for our data. Okay. So the positive and negative in healthcare is one of the example of the asymmetric binary. That's why we don't care with T. So if the person is negative and the other person is negative, then yeah, we do not care about this one. But if there is one person is negative and he meet another person who is positive, then yeah, we need to do something. Okay, we need to trace the behavior and etc. There's another kind of measure, we call it Jacob coefficient. So we call this similarity with the Jacob, and this is the formula: Q divided by Q plus R plus S. So I guess you already know the Q is here, the R is here, and the S is here. Okay. So now let's see one example. We have Jack, Mary, and Jim. Okay. And gender is asymmetric attribute. Okay, M, F, and M. The remaining attributes are asymmetric. We have fever, cough, and then there are 4 kind of tests. Okay. Test 1, test 2, test 3, and test 4. Fever, yes, yes, yes. Okay. No, no, sorry, negative, negative, and positive. Okay. So let be the Y and P is 1, and the N is 0. Now, what is the distance between Jack and Mary? Okay, based on the equation here, we need to make this kind of contingency table. We have Q, R, S, and T. And then because we have the asymmetric attributes, we will use this formula. R plus S divided by Q, R, and S. Okay. So let's see. If I have Jack and Mary and I just want to measure only based on the asymmetric attribute. Okay, distance measure for asymmetric binary variables. Then we can make like this one. We have Jack, and then we have Mary. And then yeah, we have the 1, 1, 0, 0. Now let's see the fever. Yes and yes. Okay, so we can have 1. And then P and P. Okay, they are 2. Okay, so we put here is 2. For the Q is 2. What is the remaining? So if Jack 1, if Jack positive, and Mary is negative. No. Okay. And then what about if, sorry, maybe, sorry, I did it all. See, I have, okay, I have 1, 0, and 1, 0. Maybe to make it clear. So there are 2 for 1 and 1, and then when Jack equals to 1 and Mary equals to 0, we have 0. Okay. And then what about if Jack 0, Jack negative, Jack negative, Jack negative, Jack negative, and Mary is positive? Okay, we have 1. Okay. And what about if we have the 0 and 0? Okay, 1, 2, 3. Okay, so we have 3. Now we have this one as Q, R, S, and T. So the formula will be R plus S divided by Q plus R plus S. Then we have R is 0 plus 1, and then we have the Q is 2 plus 0 plus 1. then the result is 0.33. Okay. What about Jack and Jim? Okay, you can also do the same. Okay. Jack and Jim. One, zero, zero. Okay. Then, yeah, if Jack, Y. Okay, they have fever. Okay, and then cough, test 1, test 2, test 3, test 4. Okay, so it seems we have only one for this one, and then N and P. So the Jack is negative is 1, and then Jack is positive and Jim is negative, so we have 1, and then the other is negative, 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 and negative, and negative, so we have 3. Okay, then we have 1, which is the R, and then plus 1. Okay, and then we have the Q is 1 plus 1 plus 1. Okay, so the result is 0.67. Okay, so yeah, using the same way you can measure the Jim and Mary. Okay. We can use the standardizing numerical data. Okay. Oh, sorry, we don't need to use this one. Okay. For the similarity, yeah, we can use any other way. Why I put this one? I think this is belong to the previous one, the normalization. Okay, I'm sorry. So we can do with data matrix and the dissimilarity matrix like this one. Let's suppose I have the data. I have the data matrix like this one. I have x1, x2, x3, and x4. What is x1? X1 is the data. Okay. Attribute 1, let's say this is the attribute 1. And then attribute 2, this is the attribute 2. Okay. Attribute 1 is 1 and attribute 2 is 2. So this is the x1. Attribute 1 is 3, okay, and the attribute 2 is 5. So this is 3 and then this is 5. So this is x2. Okay, and so on. We can measure the dissimilarity matrix and we will get the result. The distance between x1 and x1 is 0. Okay. The distance between x2 and x1 is this number. Okay. So we can measure the distance between x1 and x2. So there is a distance between those two objects. Yeah, we will use this kind of data matrix and dissimilarity matrix. There's one measure, we call it Minkowski distance. The Minkowski distance is a popular distance measure, and this is the formula. Okay. And we have, yeah, it's, and then we have the xi1, xj1 power of h, and plus xi2 minus xj2 power of h, and so on until the p dimension. Until p dimension. We also call this distance as L h norm. Okay. So L h norm, what is the meaning by h? H is any number. It is any integer number. And yeah, we will check later with one example. So there are properties for this similarity matrix. We can deal with the Dij. It should be greater than 0. So the distance will be higher than 0, or otherwise, if it is 0, then it is the same location, or it is the same value for the object. So we call this is the distance between I and I. If the distance they are the same, dij and dji, so we call this is the property of symmetry. And there is another property, we call it triangle inequality. So the distance between I and j, it will be lower than or equal to distance of I comma k plus distance of k comma j. So let's say I have I here and I have j here. Then the distance here and here will be lower. Sorry, the distance of I and j will be lower or equal to dik plus dkj. Because this is the triangle inequality. A distance that satisfies this property is a metric. So we call it, this is the metric of the similarity. Now we can see there are three. Okay, we will learn about the 3 aids. What is the meaning by aids here? So it is the special case of the Minkowski distance. I explained to you about the aids here. Aids. So this aids will be replaced with an integer number. Let's say the aids equal to 1. Then what happened? We call it, this is the Manhattan distance. Or yeah, people also mention that as a city block. Or we call L1, because the h equal to 1. This is L1 norm, and the other name is Hamming distance. It is the number of bits that are different between two binary factors. So we want to calculate between xi1 and xj1, and then we make the absolute. Okay, so if we put this one as 1 and we put this one as 1, then we will get this formula. What about if we have h equal to 2? We call it L2 norm, and we call this is also Euclidean distance. So the formula will be like this one. So you can apply the h equal to 2 in this part. Okay, so if it is 2, then if it is 2, yeah, you can have this formula. The other h is infinite. We call it supremum, or we call it, this is L max norm or L infinite norm. So this is the maximum difference between any attribute of the factors. So you can see this is the original formula with limit until the infinite. Okay. And we want to sum all the values with the h until infinite with the square until infinite. And at the end, we can just mention that this is the maximum. So we want to find the maximum value. So let's see. This is the Minkowski distance. Okay. We have this attribute. Okay. We have this point. Okay. We have x1, x2, x3, x4, and we have the value like this one. So what is the result from Manhattan distance? So we can see here, if we want to measure between x1 and x1, then the distance is 0. Okay, for all the distance will be 0 for all method, Manhattan, Euclidean, and supremum. What about the distance between x2 and x1? For the Manhattan, we will just do the very simple absolute value. So 1 minus 3 plus 2 minus 5. What is the result? This one is 1 minus 3 is minus 2 because we have the absolute, so we have 2. and then plus 2 minus 3, it is minus 3. We have the absolute, so we have 3. So the result is 5. So the distance between x2 and x1 is 5. What about the Euclidean distance? Yeah, we have the same formula like this one, but we put the square, okay, plus the 2 minus 5 square. So we have 2 power of 2, which is 4, and then 3 power of 2, which is 9. So we have the value is 13, and we will do the square. So the square root, okay, the square root of 13 is about like 3.61. What about the supremum? For the supremum, we have x2 and x1 same. Okay, 1 minus 3, and then we have the absolute, and then 2 minus 5. We again do the absolute. And for this one, we have 2 and we have 3. So what is the maximum? The maximum is 3. So we put this into the distance of the supremum. Okay. Yeah, we have another kind of similarity like this cosine similarity. So this cosine similarity is a kind of similarity between the numerical. Okay, so we have numerical attributes, and we want to measure it. So in this case, we have document 1, document 2, document 3, document 4, and in every document, I want to see how many word of theme. So in document 1, there are 5. So the word theme, there are 5. The word theme, there are 3 in document 2, and so on. So using this information, we want to measure the cosine similarity. I think I will stop here for the quiz.